Welcome to all S&D College of Engineering and Research Center, Yola. I am Assistant Professor Ahir Ma'am from first year department, Engineering Physics. Today we will discuss about numericals based on de Broglie hypothesis. We know very well unit number 3, wave optics. In this lesson we have already learned de Broglie hypothesis. Today we will solve examples. So move on to our first numerical. De Broglie wavelength of electron in energetic beam is 7.2 into 10 raised to minus 11 meters. Calculate the momentum and energy of electrons in the beam in electron volt. So in this example we know lambda means wavelength. Lambda is equal to 7.2 into 10 raised to minus 11 meter. We know de Broglie hypothesis relation, lambda is equal to h upon p. If we have to find momentum, then rearrange this equation. Momentum is denoted as p, then p is equal to h upon lambda. Then energy E is equal to p square upon 2m. Then momentum is equal to p is equal to 6.63 into 10 raised to minus 34. This is the Planck constant value of h upon lambda is 7.2 into 10 raised to minus 11. Then momentum is equal to 0.9208 into 10 raised to minus 23 kilograms meter per second. Then next we have to find energy. We know value of P, then 0.9208 into 10 raised to minus 23 bracket square upon 2 into m is the mass of electron, then 9.1 into 10 raised to minus 31. Then energy is equal to 0.04658 into 10 raised to minus 15 joule. The energy is converted to joule into electron volt, then 0.04658 into 10 raised to minus 15 upon 1.6 into 10 raised to minus 19 electron volt. Then energy is equal to 0.0291 into 10 raised to 4 electron volt. Next example, determine the velocity and kinetic energy of a neutron having de Broglie wavelength 1.0 degree angstrom. Then mass of neutron 1.67 into 10 raised to minus 27 kg. We know relation lambda is equal to h upon mv. Then we have to find v is equal to h upon m lambda. And h is the Planck constant, 6.63 into 10 raised to minus 34 upon mass of neutron is 1.67 into 10 raised to minus 27 into v 10 into minus 10. Then v is equal to 3.97 into 10 raised to 3 meter per second. Again we can write lambda is equal to h upon under root 2me. Then E is equal to h square 2m lambda square. Then E is equal to, we know all values, value of h, value of m and value of lambda. Then 6.63 into 10 raised to minus 34 upon 2 into 1.67 into 10 raised to minus 27 into 10 into 10 raised to minus 10 bracket square. Then E is equal to 13.16 into 10 raised to minus 21. This energy value is in joule. If we have to find energy value in electron volt, then this is 8.225 into 10 raised to minus 2 electron volt. Next example, Calculate the wavelength of electron of energy 291 electron volt. Then energy is E is equal to 291 into electron volt is equal to 291 into 1.6 into 10 raised to minus 19 joule. Formula required: lambda is equal to h upon under root 2 me. The electron wavelength is lambda is equal to h upon under root 2 me is equal to 6.63 into 10 raised to minus 34 in under root 2 into 9.1 into 10 raised to minus 31 into 291 into 1.6 into 10 raised to minus 19. Then lambda is equal to 0.7202 into 10 raised to minus 10 meter. Therefore, lambda is equal to 0.7202 degree angstrom. Next example, calculate the Broglie wavelength of a neutron having kinetic energy of 1 electron volt. Then de Broglie wavelength is given by lambda is equal to h upon under root 2 me. We know all values h, m and e. Then lambda is equal to 6.63 into 10 raised to minus 34 upon under root 2 into 1.67 into 10 raised to minus 27 into 1.6 into 10 raised to minus 19. Then 2.87 into 10 raised to minus 11 meter. Then 0.287 degree angstrom. Next problem, a proton and an alpha particle are accelerated by the same potential difference. Show that the ratio of the de Broglie wavelengths associated with them is 2 under root. Assume the mass of alpha particles to be 4 times the mass of proton. Then mass of alpha particle is equal to 4 mass of proton. Then mass of alpha is equal to mass of alpha particle. Mp is the mass of proton. Q alpha is equal to charge of particles. Qp is the charge of proton. Then Q alpha is equal to 2 Qp. Then V is the accelerating potential for the particles. We know formula lambda is equal to h upon under root 2me. Then lambda p is equal to h upon under root 2mp dot qp into v. And lambda alpha is equal to h upon under root 2m alpha into q alpha into v. Therefore, lambda p upon lambda alpha is equal to h upon under root 2mp into qp v into 2m alpha into q alpha into v upon h is equal to under root 2m alpha upon 2mp into under root q alpha upon qp. Then under root 4 under root 2 is equal to 2 root 2. Hence this is prove that. And last example, at what kinetic energy an electron will have a wavelength of 5000 degree angstrom. Then formula required, lambda is equal to h upon mv. Then we know values, lambda is equal to 5000 degree angstrom converted into meter. Then mass is equal to 9.1 into 10 raised to minus 31 kilograms. Then h is equal to 6.63 into 10 raised to minus 34. Then v is equal to h upon m lambda into 6.63 into 10 raised to minus 34 upon 9.1 into 10 raised to 31 into 5 into 10 raised to minus 7. Therefore, value of v is equal to 1.457 into 10 raised to minus 3 meter per second. Then kinetic energy is equal to 1/2 mv square. 1/2 into 9.1 into 10 raised to minus 31 into 1.457 into 10 raised to 3 bracket square. Then kinetic energy 9.66 into 10 raised to minus 25 joule. hope student you have understood all the problems. Thank you.